Have you ever stopped to think about all the little scientific mysteries that happen around us every single day? Like when a puddle just vanishes, where does it actually go? Well, today we're going to put on our detective hats and solve some of water's most clever disappearing acts. Let's get into it. So our whole investigation kicks off with a really simple question. It's one that popped up between two friends, Aubrey and Therav, while they were just chilling with a cold drink on a hot day. The ice clinking around in their glasses got them thinking, is this solid stuff floating in here really the same as the liquid we're drinking? Okay, so on one side of the debate, you've got Aubrey Mamari, and her logic is pretty straightforward. They feel totally different. You can pick up an ice cube, right? But try holding water. It just slips right through your fingers. But then you have Therav. He's arguing that, hey, you put liquid water into the freezer and you get solid ice out. So they've got to be the same thing. So who's right? And the answer is ding, ding, ding. Thera is totally on the right track. Ice and water are, in fact, the exact same substance. Good old H2O. They're just wearing different outfits. Scientists have a name for these outfits. They call them states of matter. So, here's the key difference. As a solid, ice keeps its own shape. That's why you can hold it. But as a liquid, water is a total shapeshifter. It just flows and takes the shape of whatever container it's in. So you see, Avery wasn't wrong that they behave differently, but it's all about their state, not what they're made of. Mystery number 1 solved. All right, one mystery down. Now that we know water can change its form, let's jump into our next case. And this is one that happens all the time, right under our noses, especially after it rains. You've definitely seen this, right? One minute there's a huge puddle on the playground or the sidewalk, and a few hours later you look again and it's just gone. Nobody came and mopped it up, so where did it all go? Now, this was Therav's first hypothesis, and it's a good one. It makes a lot of sense. When he saw the puddles shrinking at the park, he just figured the ground acted like a giant sponge and kind of drank it all up. But is that the whole story? Well, to see if soaking in is the only answer, let's do a little experiment, just like the one in our source material. We'll put a little water on a solid steel plate. Now, we know for a fact that water can't soak through steel, right? So if the water disappears from here, it has to be going somewhere else, and not down. And what do you know? After a little while, the water's gone. Poof, vanished right off the plate. It didn't leave a trace, and it definitely didn't leak through. The plot thickens. This tells us that the ground soaking it up can't be the only explanation. The water went somewhere else entirely. And this, my friends, brings us to the big reveal: evaporation. The water turned into a completely invisible gas called water vapor and just floated up into the air. Basically, the sun's heat gives the tiny water molecules enough energy to escape and go on a little adventure into the atmosphere. And once you know about evaporation, you start seeing it everywhere. It's the magic behind your clothes drying on a clothesline, it's why a mopped floor doesn't stay wet forever, and it's even how sweat cools you down when it evaporates right off your skin. Okay, we have unmasked 2 of water's greatest disguises, but there is one more everyday mystery to solve, and this one is a real head-scratcher. It's all about turning that invisible gas we just talked about back into a liquid. I want you to picture this. It's a warm day, you pour a nice ice-cold glass of water. You set it down, and a few minutes later, the outside of the glass is covered in little water droplets. It looks like the glass is sweating. But where is that water coming from? Therav's first guess was that the glass must be leaking. And that seems pretty plausible, doesn't it? Maybe there are teeny tiny microscopic holes in the glass and the water is just seeping right through. But then Avery makes this brilliant observation. She points out that if the glass were leaking, even a tiny bit, the water level inside the glass should go down. But look, it hasn't budged. It's exactly where it was. So, the leaking theory is officially busted. That water has to be coming from somewhere else. And this is where it gets really cool. The water isn't coming from inside the glass at all. It's coming from the air. Remember that invisible water vapor we just learned about? Well, it's all around us, all the time, floating in the air. The scientific name for this amazing trick is condensation. It's basically evaporation in reverse. When that warm, humid air touches the super cold surface of the glass, it gets chilled fast. And that cooling forces the invisible water vapor to change its disguise again, turning from a gas right back into the liquid water droplets you can see on the glass. So let's pull all these clues together.
We've solved 3 different mysteries, and now it's time to step back and look at the big picture, how water pulls off all of these incredible transformations.
So here they are, water's 3 main disguises. You've got solid, like the ice cubes in our drink. You've got liquid, like the water we actually drink. And you've got gas, that invisible water vapor that's just floating in the air all around us. It's all the same stuff, just in a different costume. And this little chart here just maps out the transformations we've been investigating. When solid ice turns to liquid water, we call that melting. When that liquid water turns into an invisible gas, that's evaporation. And when that gas turns back into liquid water, like on our cold glass, that's condensation. Simple as that. Now, why does any of this matter? I mean, a puddle drying up, a glass sweating. Who really cares, right? Well, it turns out it's a huge deal, because these small, everyday changes are all part of an enormous and absolutely essential system, the Earth's water cycle. These same processes create clouds, make rain, and move water all around our entire planet. And what's really amazing is that this idea isn't new. People have been observing these patterns for thousands of years. In fact, there's this beautiful piece of wisdom about this very cycle in an ancient Tamil text called the Thirukural. It says, even the vast oceans will dry up if clouds don't give back the water they take as rain. How perfect is that? It perfectly captures this idea of a continuous give and take. Water evaporates up from the oceans, it condenses into clouds, and then it returns as rain. It's a perfect self-sustaining loop. So now you're in on the secret. The next time you see your own breath on a cold day, or you notice the morning dew on the grass, you'll know exactly what's happening. You're just spotting water in the middle of one of its incredible costume changes. So the question is, now that you know what to look for, where are you going to see it next?